For the first question, we're asked to predict the product of the reaction and select the reagent to use. In this case, NaBH4 is the reagent that we need to reduce a ketone. So NaBH4 is for ketones and aldehydes. LAH or LAH4 is for everything else. So when this is reduced, the product would be the alcohol functional group. So we converted the ketone to a secondary alcohol. Now, when this is presented, a better representation of reagents is in step 1, we're going to add NaBH4, and unless nitrogen is involved, then we're going to do an acidic workup, which is going to be H3O+. And a quick reminder for the mechanism, if we have our sodium borohydride, so we've got 4 hydrogens attached to boron. In the first step, we're going to do a nucleophilic attack on that carbon, the carbonyl carbon, to get us to our intermediate, which is our cyclohexane ring, and now we have an oxygen with a negative charge. And then we are going to use our workup solvent, which is H3O+, so a weak acid in solution. So OH2, plus charge on there, and we're going to use these electrons on the oxygen to deprotonate that to get us to our final product, which again is a secondary alcohol. For the next one, if we have our amide functional group, so our carbonyl carbon bonded to a nitrogen, we need to use a stronger reducing agent, LAH4, and with this workup, we're actually going to use water instead of H3O+, and also this bond is not going to be broken. So we're going to fully reduce this ketone and make that a CH2, but this bond will not be broken. So that's one major difference if we have our amide, and remember that nitrogen-carbon bond is the strongest of all of our carboxylic acid derivatives. So here we have our cyclopentane ring, and now that carbon double bond oxygen that was there is now a CH2, and we still have our NH2. Alright, we have an ester functional group here. We need to use a stronger reducing agent, LAH. Now in this case, that bond will be broken. So we're going to convert our ester into 2 alcohols. So in this case, 2 primary alcohols. And actually, the carbonyl carbon of the ester, that will always become a primary alcohol because we have a double bonded oxygen to it. So here we have the isopropyl group. We converted, this bond has broken, and we're going to protonate that oxygen. So we have HO and then our isobutyl group. Alright, for the next one we have an aldehyde. We can easily reduce that with NaBH4. We're going to reduce that to a primary alcohol, OH. And for the next one we have a carboxylic acid. We need to use our stronger reducing agent, LAH, to reduce that to an alcohol and water. And for the next, again, we have that amide functional group. So this nitrogen carbon bond will not be broken. We need to use the stronger reducing agent to fully reduce this to a CH2. We still have NH, and we still have that there. And again, with the workup solvent, this is a little bit different than the others because we can't use a strong acid, because if that happened, we would just protonate our nitrogen. So this would be LAH4 in the first step, and in the second step, we would use water as our workup solvent. Alright, for the next we have a ketone functional group. We need to use NaBH4. We've got 2 terbutyl groups there, and that's connected to that carbon. Now we have an alcohol functional group. For this we have an aldehyde functional group again. So we're going to convert that to an alcohol. So over 2 methyl groups there, the rest of our carbon chain is the same. Here we need to use a stronger reducing agent, LAH, to reduce that carboxylic acid to an alcohol. And for the last one, we have an ester. So again, this bond is going to break. We need to use LAH